Hello students, I have come up with one more challenging problem for you in the magnetic field, in the field of magnetic field flux variation. The problem is like this, have a look. A rotating disk in the magnetic field acts as a generator. If you have a disk rotating in the magnetic field, it can be used as a generator. It can be used as a source of EMF. It can be used as a source of potential difference, which can run refrigerator, which can run a heater or lights, a bulb. It can run. So how it can be done like that? So it is a disk here. It rotates the magnetic field, and there is a change in magnetic flux. The center of the disk becomes positive in some cases, and the periphery of the disk becomes negative. And you take the connections from the periphery, sliding connection. Of course, there should not be it should not be connected that connection which will wind it up. It should be a sliding connection. I mean, the disk should rotate. It should touch this rod, not wind it up. And also there is an axle through the center of the disk, which acts one more electrode. The center of the disk becomes positive in some cases, and the periphery becomes negative. It can happen in reverse. If you change the magnetic field direction, it can become negative, it can become positive. But that is not the point. The point is there is a potential difference created between the center and the periphery. A disk rotating in the magnetic field, that's all. When a disk rotates in the magnetic field, we have to see how potential difference gets created from between the center and the periphery, and we take the connections between the center and the periphery, and that acts as a source for EMF, as a source for voltage, right? Okay, first of all, let me explain the concept. The concept is like this. It's a disk here. It's a disk, and let me suppose this is the magnetic field, dot type magnetic field, that is outward magnetic field. Outward magnetic field. And the disk starts rotating with omega. From the center to the periphery, you draw a line as a radius vector. That means this radius vector, when the disk rotates, this radius vector also rotates like this. If you consider this radius vector to be a rod-like, it's a thin rod, you can take it like that. It rotates and it cuts the magnetic field. This radius vector cuts the magnetic field. Magnetic field is like this, outwards, right? And the disk rotates, this disk rotates, and the radius vector of the disk rotates like this. It rotates like this. It rotates the magnetic field. This rod rotates the magnetic field. The rod is something like the radius vector. I consider it to be a rod. Through imagination, I consider it to be a rod, and I consider this disk to be made of these little rods. They are rotating and cutting the magnetic field. When the magnetic field is cut, when it makes one revolution, how much magnetic field is cut in this revolution? How much area, how much flux has been cut? What is the flux? When the rod, disk makes one complete revolution, how much flux is cut? Flux delta phi is equal to, that is see here, something like this, complete rotation. The area is, it traverses the area, it traverses the whole area of the rod like this. That is pi r square into b. That is the flux cut. Magnetic field and the area. This is the magnetic field, and this rod cuts the whole area like this. It cuts the whole area like this. Cuts the area. And magnetic field is this way, and pi r square b. Okay. Now, in how much time induced EMF is delta phi by delta t? This flux is cut in how much time? Because when it makes a complete revolution. It makes complete revolution, suppose in time t, time period t. So induced EMF is negative of del phi by del t. Del phi is pi r square b divided by, what about t? That is time period in one revolution, that is t. So E equal to that is induced EMF, there's potential difference in a way, that's pi r square b, what is t? That is 2 pi by omega, because omega is equal to 2 pi by t by usual definition. This cancels and it is minus 1 by 2 omega b, this one, into r square. So magnitude of EMF, this negative means is this negative or is this positive or this negative or this positive, that gives this negative, gives the sense. Okay, but magnitude is 1 by 2 omega b r square. This is the induced EMF. I mean, if this coil, this disc rotates in the magnetic field, this is the magnetic field, this is the disc, it rotates and it will produce the induced EMF between what and what? Between the center and the periphery, because of this mechanism. This, in this case, if the omega is rotating like this and it is consider this velocity like this, v cross, it is v, it is b, v cross b. In that case, this will become positive, this will become negative. उसके लिए वो लॉरेंट्ज फोर्स का कॉन्सेप्ट है. अगर ये v है, नीचे की ओर डिस्क आ रहा है, ये रॉड समझो नीचे की ओर आ रहा है, ये वेलोसिटी है और ये बाहर की ओर मैग्नेटिक फील्ड है, v को b में क्रॉस करो तो पॉजिटिव चार्ज यहाँ की ओर शिफ्ट हो जाएंगे सेंटर की ओर, ये पॉजिटिव हो गया या नेगेटिव हो गया. So there is a potential difference between these 2 points when the rod rotates in the magnetic field. So this is the induced EMF. Now the question is, if magnetic field here in this disk, passing through this disk is 0.9 and radius is 0.4 meters, and you need to create a potential difference between this point and this point, 25 volts to be used in the external circuit, what should be the omega? How much it should rotate per second? I mean, what is the angular velocity, or f? How many revolutions this should make in 1 second? So you have to use this formula. So if I use this formula, what is E? What is omega from this equation? So E is equal to 1 by 2 omega b r square. Now, what is omega? Omega is equal to 2 times induced EMF, 2 times induced EMF divided by b r square. Omega is equal to 2, what is induced EMF? 25 volt divided by what is b? That is 0.9, and what is r? That is 0.4 square of this, right? Okay. Okay. Now f is equal to omega by 2 pi, because omega is 2 pi f, is equal to omega को वहां लाइए, that's 2 into 25 by 0.9 into 0.4 whole square multiplied by 2 multiplied by pi 3.14, right? Okay. Now f is equal to 3.317 into 10 raised to power 3 revolutions per minute. This is the answer. These many revolutions, 3,000, almost 3,300 revolutions per minute it should make to produce 25 volts of potential difference between these 2 points, and this potential difference can later be used for applications. This was the 10th challenging problem. It will continue, and you just watch my lectures on the YouTube, and also download the literature from my app, that is Tantray physics classes, and I hope that it will help you in cracking the national IIT level examination. Thank you.